Gentlemen, a very good evening to you all. It is indeed an enormous achievement and a pride for me as the president of IET on campus KDU to announce the commencement of the second event for this year calendar of IET on campus KDU. Amid the prevailing circumstance of current COVID-19 pandemic, we had to organize this webinar across a virtual platform. Ladies and gentlemen, never become so much of an expert that you stop gaining expertise. View life as a continuous learning experience. Yet, we have a light audience of scholars, striving to learn even if best would best of the industrial experiences. Ladies and gentlemen, I would like to welcome our keynote speaker of the session, Engineer Migara Amithodhana, Dr. Uday Dampage, the Dean Faculty of Engineering KDU, who always backs us up to make progress every day, and Commodore J.U. Gunasila, the Dean Faculty of Computing KDU and Professor of the Department of Electrical, Electronic and Telecommunication Engineering, Professor J.R. Lucas. Not only that, but also my warmest welcome is extended to all the participants present today from KDU and other universities of the island. On behalf of my Board of Management of IET On Campus KDU, as President of IET On Campus KDU, I am honored and most privileged with your presence today. As engineering students, we have to choose the right path if our intention is to succeed. Ladies and gentlemen, our keynote speaker today, Engineer Migara Amithodhana, is a chartered engineer by profession with over 8 years of industry experience in IT sector in Sri Lanka. He obtained BSc Engineering degree majoring Electronic and Telecommunication from University of Moratuwa and Masters of Business Administration from University of Colombo. He currently works as a regional manager at Sri Lanka Telecom, overlooking sales, operations, and planning of telecommunication services. He is also a partner of A&T Labs, which promotes innovative technologies for the industries in Sri Lanka. A&T Lab has produced award-winning industrial solutions with technologies such as IoT, robotics, electronics, edge computing, and cloud computing. Ladies and gentlemen, let me now cordially invite Engineer Migara Amithodhana, our keynote speaker today. Over to you, sir.
Thank you for that wonderful introduction, Pasan, and thanks for the opportunity given to me to conduct this lecture, and special thanks goes to all the staff members, dean, and all the faculty members as well. So I hope you all can hear me and you all can see my screen clearly. So let's move on with the session today. So this one I would like to share as not just as a lecture. So this is going to be some of my experiences, some of the perspectives I see in the Internet of Things in the industry today, and some of my exposure in some areas related to the industry. So it is not a hardcore lecture with the theories and all, but rather I would like to focus this towards practical side, some of the practical applications, and some parts that I think that will be essential for you and useful for you all. So let's move on with the session. First of all, I think Pasan gave me a wonderful introduction, so no need to introduce about myself. So the contents of this presentation would be about IoT or Internet of Things introduction. What are the layers and architecture of IoT, and what are the applications in the world as well as in Sri Lanka, and where the industry is heading with the current trends, and what are the innovations that we have done and what we can do, and what are the IoT platforms available for you all to test it out and see and implement some of your applications, or maybe do some of your final year projects or student projects. And of course, if you are interested in developing solutions and exploring the huge market out there available for IoT solutions, where you should start. I think those are the areas I'm going to cover in this presentation. So at the end, what I want you all to think is, I want you all to be inspired to do your part, because I know that most of you are engaged in technical areas, or maybe if you are studying some other area as well. Uh, if you are inspired to do your part for the country or to the world, or to solve a problem that the mankind needs a solution, I think that's what I intend to do with this presentation, for you all to be inspired that these things can be done. These things are not just presentations, videos, or something that you just see and ignore. These things are practical things that we all can do. And as a student, you have a great role to play in this sector. And that's the end message that I want to give you all. So to start off with the IoT, and it is said in the 2020 World Economic Forum report that IoT devices will dominate the industries during the next 5 to 10 years. Now, as you can see here, more than 80% of the industries is going to adopt IoT related technologies. Now, of course, you would understand that we cannot live without internet. Even we are doing this session via internet. So not only for learning purpose, for all the industries, we need internet. So it's not just about going humans online and collaborating. Soon it will be all about, and it's already happening, that machines are going online and machines are collaborating to provide the results we need. So that's all about IoT in a nutshell. So this is what's going to happen during your career, during your lifetime. You will see this change. I think most of the staff members here would have experienced that during the last 10 to 15 years, we have seen massive developments when it comes to mobile applications, web developments, and the next phases of this development will be based on the technologies like IoT, AI, machine learning, these things. So that's why everybody is talking about Industry 4.0 nowadays. With all these automations, human processes are getting automated, humans are getting replaced by machines, and we are talking about machine to machine communication nowadays rather than human machine interfaces. So it's all about Industry 4.0. Some technologies like advanced electronics, robotics, and programming, AI, these things have enabled another leap in the technology, which is called a technical revolution. And that is what is indicated as Industry 4.0. And now already everybody is interested about Industry 5.0 as well. So what will be the next phase of this revolution? And to brief you now, this Industry 4.0, how we came here. Now, as you can see here, the Industry 1.0 is the mechanization with the steam engine, which is a revolution in the industries with all the machinery, automobiles, and all that. And Industry 2.0 is recognized as the mass production with assembly lines and electrical power, with the invention of the electricity to mechanize the processes available. And the third industry revolution is known as the automated production, computers, IT systems, robotics, these things. And in the future or current, at present, what is happening is Industry 4.0 signifies the smart factories, autonomous systems, IoT systems, and of course, machine learning, AI, these kind of things signifies the current Industry 4.0. So it's all about robotics, cloud, big data, AI, and nanotechnology, 5G. All these things are related to Industry 4.0. Now, if you take all these words, these are just buzzwords. Now, everybody's talking about big data, AI. Now, I think one of the areas you have to worry as a student or as a professional is not to limit to these words, because we have seen that many people love to talk about these subjects, but if we are not implementing any of that, and we are just speaking the technical buzzwords, it's not going to work. Actually, in order to reap the benefits of these technologies, I think even the simplest applications with the earlier with the even simple algorithms, or maybe using big data or AI, or maybe robotics applications, likewise this technology is going to work, and we can adopt that only if we are going to start working with that. So I think that's the secret here we need to figure out, and that's the area that you all will have to deal in the future very soon when you are engaging in a job, or if you are engaging in an entrepreneurial journey as an individual. So that those are the things that you need to think of. So if you think about IoT, what is IoT? It's all about network of things that are embedded with systems, sensors, software, and other tech for the purpose of connecting and exchanging data. I just took this from the uh, Wikipedia, and if you refer IEEE, and they have a separate very theoretical explanation about IoT. So basically, it's all about connected devices communicating with each other to provide uh, an intended task. So that's all about IoT. And one thing we have to clear up with IoT is not just a technology. If you take something like programming, it's all about coding with different programming languages, right? But if you say I'm an IoT engineer or I'm an IoT person, so what are you doing? Are you doing something called IoT? I think it can be more explained as an umbrella term given to a combination of technologies like electronics, programming, communication, cloud, and likewise. So it's a collective term actually. So if you are developing an IoT solution, you have to have knowledge in all these areas. I don't mean that you have to be an expert or the perfect person who has some high-end knowledge about all these areas, but you have to have the necessary knowledge to develop the solution that you intend to do. So that's the secret, I guess. So it's all about being like, as they say, it's all about being a jack of all trades, right? Nowadays, if you are into technology, if you are into engineering, it's all about knowing all these areas, not just about specializing a single area. It's good to specialize a single area. I'm not underestimating that. It's really good. But you have to have knowledge in other areas as well in order to develop good, robust solutions. So if you take IoT, it could be vary from very small devices to very large devices. It could be a very small sensor like the size of your thumb, or maybe a very large device like an aeroplane or satellite. Likewise, it could be a very small thing or a very large thing. All these are connected to the internet. And if we talk about the scale, how it's going to happen, now as estimated in the year 2018, it was like 22 devices connected to the internet. This is all the computers, all the sensors, nodes, everything. So in the year 2025, it's going to be around 40 billion. This is billions, right? So in 2030, it's going to be 50 billion, right? I hope you all are aware that the world population right now is around 7 billion. So even now, we have about 25 to 30 billion devices. So it's about 4 or 5 times than about the population size in the world. So we can see more and more devices are coming online, connected to the internet. And this trend will continue as per predictions. And that is why I said earlier as well, you all will see this during your lifetime. You all will have the chance to experience what I'm talking about during your lifetime. I had the same experience about these apps. So when we were in the university back in about 2008 or 2009, now there was everybody's talking about these mobile apps and app developments and all that, and we saw the rapid phase it grew to the level today during our lifetime, during the last decade. And I'm sure you all will see the development of IoT during this decade in your career. So that is the challenge that we have ahead in terms of devices. So if you go to the subject, what are the layers of IoT? There are three main layers. Now, this is not the actual architectural view into deep technology. I am explaining this in the most simplest way you all can understand and work out a solution. So if we take in a nutshell, there are three layers: things, the network or the gateway layer, and the cloud. So these are the three layers that make the make IoT actually, or a IoT solution. So if we talk about things, it's all about sensors and all that. And gateway or the network layer is briefly about the communication medium. And cloud is all about the cloud as we know it. So if we talk about things, now when we talk about Internet of Things, a major part of it is the things. So what are these things? All the devices which are connected to the internet. So it could be sensors like small electronic devices capturing parameters like temperature, humidity, proximity, GPS, and accelerometer. And if you take even your smartphone, and it has so many sensors, like the apart from the sensors I have mentioned here, like the pressure sensors, accelerometers, gyroscope, and light sensors. And so there are so many sensors integrated even to a mobile phone. And apart from that, another type of devices are actuators. It could be motors, bulbs, switches. And another part is human interface devices like our household appliances, PCs, tabs, and all that. And there could be computers, smart devices, and also the we can count the routers, switches, and all that as well into the devices. So these are the things, these are the devices that makes that 30 billion odd things in the IoT around the world. So these are the things that we can identify in IoT. On the other hand, what is the network or the gateway layer? So the network layer is comprised of communication technology. So it could be wireless, like using Wi-Fi, NFC, Zigbee, LTE, 5G, LoRa, NB-IoT. There are many wireless communication technologies that I have not mentioned here as well, like LoRa, or maybe there are things like Li-Fi. So there are many wireless communication technologies available. So any of those technologies can be used in IoT because it's all about connecting devices. So if you are connecting devices, you can use any of these mediums. And the beauty of that is you can use the wireless communication methods very easily because of two reasons. One reason is the communication modules, as we know it, is getting very smaller and smaller. So we can embed the communication modules at the sensor end itself. For example, we can now develop a simple smartwatch like this directly connecting to the internet, which we cannot in back in about 10 years back, which we cannot do. So communication modules are getting very smaller. On the other hand, it's very easy to connect devices using wireless technologies because you don't have to simply wire something. and it's very easy to implement in any environment because you don't have the hassle of wires. So you can use any of these communication technologies in IoT solutions. On the other hand, in the industrial environments, you can use wired communication as well, because it's also a very reliable method of communication. If we think about the industrial solutions, when we want stable connections, or if we have already laid connections between devices, we can use Ethernet, power line communication likewise, and there are many other methods that we can do with wired communications as well. So it's all about the communication layer. It is similar to any other solution that you are doing. And the other part is the cloud. So when we are talking about IoT, we cannot get rid of cloud because these things are interconnected. Now, why we are using cloud? In the next slide, I'm going to show you the general benefits that we all talk about in cloud technologies. But why we use cloud technology in IoT is mainly by using IoT solutions. What we are doing is gathering data. When we implement so many sensors or sensor networks, what we are doing is capturing data. So we need to gather or aggregate this data and store it somewhere. So what is the most scalable and reliable method to store data nowadays? In the cloud. And on the other hand, cloud has the capacity and the processing power. And of course, you know, the cloud platforms, they have very scalable processing power as well. When your data set is getting bigger, you can get more processing power as well. So it is useful to process the data and to analyze it as well. And on the other hand, using the cloud technologies, you can represent or visualize the data. So it's simply as to, to put that simply, you can develop dashboards, websites, or maybe integrate this into another system or a software or a website. So it's all about integrating and showing your data to the customer or to the end user. So all these things you can do very easily with the cloud technologies, because and even without cloud you can do this. But if you're doing this without the cloud, you have to have the proper infrastructure with the servers and other software need to run a server locally. So you have to have the other resources as well. So that is why we are very conveniently using cloud technology nowadays. And as I mentioned earlier, cloud has these are the general benefits of cloud technology, like the low cost, flexibility, and you can collaborate from anywhere. It has the security. And I think one part I have not covered in this presentation is the security side. I think that is an area open for discussion and you all to think, because all these applications, when we are implementing in industrial environments or even in the practical life, there could be vulnerabilities as these data are exposed to the internet, or maybe we are storing it in a cloud application. So if we take the general cloud platforms that we are going to discuss during this session, they have inbuilt security features. And even in our solution at the lowest end, we have to think about security features as well. How we can stop someone getting unnecessary or unauthenticated access to this information. Because as you can see, when 30 billion odd devices are connected to the internet, if somebody on the internet can hack into maybe even a very small portion of these devices, it will be a disaster. And those disasters have happened. And if you check on the internet, I think you will see that certain attacks on IoT devices have caused damage to some industries, have stopped factories and supply chains completely, or maybe caused damage to all the household appliances connected to the internet. So that gravity is there when it comes to IoT. So security is a very concerned area. So that I am not going to deeply discuss in during this session. I open that area for you all to think about in future. So I talk about three layers: the devices, network, and the cloud. So if we take a very simple example to explain that, This is a GPS tracking system which very common thing nowadays. So the GPS tracker on the device is the device here, and the GSM or cellular network is the network layer, and the server we have where our solution or the tracking software is running is the cloud layer. So that is a very simple explanation that I can give to explain these three layers in a practical solution. On the other hand, now you all know there are certain protocols. If we take even the communication layer here, for communication, there are certain protocols. Likewise, in IoT, in order to transmit data between these nodes, or maybe from a node to the cloud, there are certain protocols that we use to exchange these data. So, of course, you can use HTTP or the standard web sockets, likewise normal web technologies, to transmit data from one node to another. On the other hand, a very popular protocol used in this IoT area is MQTT, which is a very simple messaging technique, and which I'm going to explain in the next few slides. And also constrained application protocol is also there. So all these protocols can be used to transmit data between nodes, or maybe it in a node and a cloud application, you can use that. So if we take MQTT, and it is said it's the you can use MQTT S as well and HTTPS as well, the secured versions of these protocols. It's better to use those technologies where if you are implementing a very advanced solution or a practical solution for an industry, the better protocols would be MQTT-S or the HTTPS, the secured versions of these protocols with encrypted data, right? I hope you all understand when I say it like that. So why we use MQTT? It's a very lightweight data protocol. So it uses this thing called publish and subscribe messaging technique. And it's highly ideal to connect remote devices with a simple code or a very small footprint. So that is why we use MQTT very popularly with the IoT solutions. Now, how you can use this practically? Now, when I come to the solution development side, I hope you would understand. So this is all about, if you take a simple IoT node in the market, there are many IoT nodes. Now, if you take, when you are talking about developing these solutions, now nobody expect you to reinvent the wheel. So you don't have to develop a temperature sensor again for this world, because it's commonly available and you can get it. It is very cheap. So you don't have to go into that granular level. So all you have to do is, if you take a sensor, how you can integrate that with the solution. So in order to do that, you have to get the parameters, the readings out of the sensor. So using this kind of a protocol, you have to push the information in a certain structure to a IoT platform. Then you can process the data, get it to some other platform or a software, or maybe visualize that. So that's the simple way of doing that using these MQTT protocols or data protocols. So how we use this MQTT protocol? Basically, there's something called a message broker, which is a server. So what that server does is, it routes the messages. So when you are using the MQTT protocol, all you have to do is, when you are passing a message, you have to mark that with a topic or a tag called topic, and the client device which has subscribed to that topic receive the message. For example, if I am a node in an IoT network, when I am sending a message, every time I can tag it as Migara. So all the other nodes around the world connected to this message broker or has a route to this message broker can simply subscribe to that topic called Migara, right? It's like when you are receiving the Facebook feed or Instagram feed, right? So when it comes to, it is in the device level. So all the devices who has subscribed to this topic called Migara in this message broker or connected to this message broker receives the message. So that is why we call it, it's a subscriber based protocol. So you can, if you dig more in the internet, you can learn how to use it. And on the other hand, when you are dealing with devices also, you will get to learn more about using MQTT as well. Okay, so that's about the protocols that you have to use. So what are the nodes in an IoT application? So as I mentioned earlier, there are sensors, gateways, or maybe edge computing devices and dashboards. Now these are not all the nodes in an application or components in an application. Actually, the correct word that I could have used is components in an application. So all I just wanted to give you is a practical idea. If you are developing an IoT application, what are the elements that I have to have? So it's all you have to have is certain sensors, a communication gateway, or a method to get that data to the cloud or connected to the internet, or else you have to have edge computing devices. Like you don't need a cloud at all. You process that data at the end as well. On the other hand, using that data in the cloud, you can develop dashboards, right? That is to represent the data. So that is the most simplest way that I can explain the components or the elements of an IoT application. Sensors, using gateways, we develop a dashboard. So that is even if we drop the edge computing devices part, all the other three elements are enough to develop a solution. So if we take sensor nodes, for environmental conditions, you can use temperature, humidity, proximity, rain or moisture. And for machines, using sensors, you can capture production units, number of production units, or the weight or the fault count, energy consume. If we take wearable devices, IoT for humans, even with a very simple device like this a smart watch, so you can capture pressure, temperature, step count, heart rate, and sugar level and all that. And if we take an application related to livestock or animals, now I think you all might have seen this invitation to develop new solutions to the the wild elephant issue in Sri Lanka, the wild elephant conflict, right? So that is there are many IoT solutions proposed to that solution problem as well. So different sensor nodes can be implemented depending on the different environmental and different application areas. So that is the thing that I wanted to highlight. And another thing that I want to highlight is you don't have to develop these sensors from the scratch. Many of these sensors are available. There are very reputed companies doing these solutions. So if these sensors are available, you might think, what do we have to do? Now the tricky part is, if you take a IoT solution, let's say a GPS tracking system, a GPS tracker is not an expensive device. But if we take the GPS tracker, the communication part, the software part, when all these things are integrated together as a robust solution, it costs a lot. It is very expensive. And if you take an industrial automation solution, let's say simply something to count the number of production units in a factory. So if we think about this, if we can capture it with the sensor in the machine, maybe in a machine, you would understand that implementing a sensor is not a difficult thing. But if you take implementing a sensor with the communication module, taking that data into the cloud, integrating that with the API or developing a separate thing for that, that combined solution, the integrated solution, cost a lot. And transforming the current systems to this with these new technologies is a difficult thing, because if we take the current machines in the industries, some of them don't have these sensors. So we have to implement these sensors again, and these system then current machines are not cannot be connected to the internet. So we have to figure out how to connect these devices or the sensors to the internet effectively. So these are the challenges available, and that is why we have the opportunity to develop such solutions. So how we can select a sensor? So that is why I mentioned you don't have to develop a sensor. You can select a sensor. How you can select that? Capture the correct parameter with the required accuracy level of the customer and the reliability, and it should suit your integration requirement. If you want to integrate using MQTT or HTTPS protocol, it should have certain capabilities supporting to certain protocols, or maybe certain outputs, or maybe certain voltage levels that you are operating your solution. And also availability and warranty, the commonly availability in case once you implement, if the sensor becomes faulty, how you are going to replace that, and the cost of the unit, and the lead time, because some of the sensors that are available in the market, you cannot get it readily. Sometimes if you are getting in bulk, you have to order in advance from a supplier from another country. So there's a lead time as well. So these are some of the criteria. There could be other criteria. These are some of the criteria that you have to think. For example, if we take something like a weather station, I'll show you some weather stations that we have done. So if we take a weather station, one client might just want to know the weather conditions, record them, and see the historical patterns. So they are not worried about the accuracy of the data to like 2-3 digits, right? So then we can use a certain set of sensors complying to that requirement. On the other hand, let's say if the meteorological department needs the weather parameters with high accuracy to like 3 decimal points, and in certain parameters they need very high accuracy like the precipitation or the rainfall. So then we have to use the most high-end sensors available, right? So there are certain sensors we can get from very reputed suppliers. I think you all might know about Texas Instruments, Campbell Technology. Likewise, there are firms in US, and there are very reputed suppliers in China as well nowadays, and in Europe as well. So from these companies, we can get very reliable sensors. And when it comes to sensors, one other thing is when it comes to sensors, now you might think why we have to purchase these things. So I should remind you that most of things have good reliability and very robust devices. And if you are purchasing the solution as a whole, it costs a lot. But when you are getting these sensors alone, it doesn't cost a lot. If you take very simple, very small thing like a temperature sensor or a proximity sensor, even an industrial one, or maybe a fire sensor, gas sensor, any of these sensors in the industry level, even with the high accuracy, it doesn't cost a lot if you take the sensor alone. But if you take that solution, you can check the same one with a smart interface or maybe with a mobile app. You can compare the cost and see how much does it cost in other countries. So that is where we have the opportunity, because we have the knowledge and the capacity to integrate things and develop solutions. So if you take gateways, why we want gateways? Now we got the sensor, we can get the parameters out of that sensor. So how we can implement multiple sensors, gather that data and communicate it to the cloud? We have to use gateways. So either you can design gateways with communication modules, or else there are readily gateways available, communication gateways, where you can simply plug in sensor with the industrial sensors, or maybe some other sensors you have, and plug it into a gateway device, and transmit that and program the gateway device in such a way that you carry the data to an intended position you need. Let's say you have a certain IP or a certain server, then you program by programming the gateway to transmit the data or communicate the data to a certain point in the cloud, you can handle your data. So that is what we do with gateways. Now this gateway, the picture that I have displayed here is called Things Node, which was developed by our team. And Things Node is such a gateway which handles industry level sensors, where sensor data can be transport directly to a cloud application or an existing IT system or a software as well. So it has the ease of operation, and gateway should provide safety and protection of data, as well as the physical protection for the devices and communication modules as well. On the other hand, there are edge computing devices as well. So why we call edge computing devices? Now, you all know nowadays, all these processors are getting very smaller. Now, the processing power we had earlier in a computer, now we had with a simple mobile phone. Now, the computer that I had in 2000, maybe 8 or 10, the same processing power available right now in my phone. Right? So that is the beauty of technology. It's getting miniaturized every year. So because of that, we can develop certain devices to process the data at the end. So when we are always communicating with the cloud, there could be problems, because if you want to process data, get a decision and automate something, then we have to rely on the communication. Let's say that you are operating in a no signal zone, or maybe if you are using mobile technology, if the tower goes out, what happens? Then the whole thing stops. Nowadays, since we have processing power with all these miniaturized processors, we can simply process data at the end node itself. That means if we have an edge computing device implemented, we can gather the data and process the data there itself and take a decision for automation, or maybe send a certain part only to the cloud, only a necessary part. That is how we achieve all these low power automations as well, or low power devices as well. As you can see, these Things Node IoT device that we have designed is a very low power device. So basically what these devices does is, these are battery powered mostly. So these things transmit data maybe 1 packet per day. So all this data in the cloud, but only 1 packet received per day. So all the other processing things can be done in this device end itself, right? If I explain that with an example, let's say you are counting certain number of production units, or maybe you are detecting the fault units with a sensor in a production line. And depending on the fault units, if the number of fault units are getting increased, you need to stop the production line. So let's say there's a motor and you need to stop that. So in order to get that decision, once you get the sensor input, you can process the data with the edge computing device itself and send the signal to turn off the motor from the edge computing device itself. So in this architecture, there's no need for a cloud application, right? So in case the communication method fails, there will be no problem. So that is the use of edge computing devices. It is getting more popular these days because it reduces the complexity of cloud applications. But since we have many benefits from cloud applications, we cannot get rid of that, because cloud has more capacity to handle data, store data, visualize data. All those things can be done using cloud. Right. So that is why what this cloud and the edge differentiation is also all about. It's all about centralized and decentralized systems, and the latency is very low in the edge because data is at the end, and also the full mobility is there with the edge, and location of the services with the edge, and likewise. On the other hand, if you take something like dashboards, which is very popular with IoT, you can develop a dashboard using popular web frameworks, you all know, using any of these technologies. And you can use cloud IoT applications also, because if you use a cloud IoT application, you can do that very easily without much of a hassle using different web frameworks. Most of these have GUI interfaces or graphical user interfaces. So all you have to do is drag and drop certain blocks and get this dashboard done, right? So no, you don't have to face the hassle of dealing with all these codes and all nowadays. And the other hand, you can also implement a dashboard using your own local server and hosting that. Or else, if we take the current very popular systems like ERP, CRMs, and all these systems, they have certain, if we develop a solution and if we can use the standard protocols I mentioned like HTTP and develop WebSockets or maybe APIs, so we can provide them to existing systems like ERP, CRM, and integrate with those to visualize the data. So dashboards is all about visualizing the data that we acquire, so the end users can analyze them, recognize patterns, recognize corrective actions, preventive actions, likewise. And also this historical data captured with these dashboards or the data storing in the cloud is very essential, because those can be used to identify patterns, or maybe using advanced techniques like AI or machine learning to come up with very high-end solutions in future. So with all that, let's move on to some application areas of IoT. What are the practical application areas? So very popular application area is smart homes. As you all know, different smart devices connected to mobiles, connected to computers, everywhere. So nowadays, not only your AC or lights or switches are connected, but also any of these devices like TVs, washing machines, everything. And there are even coffee machines that can be connected to the internet. So before you go home, you can order coffee while you are on the way, right? So all these things can now be connected, and there are certain home automation brands. If you take very reputed brands, all these switches and bulbs and all that are very sometimes kind of expensive even as of now. But since you all are into technology, you can figure out in very popular marketplaces, there are certain brands coming up with very low cost solutions and connecting to the internet. There are especially bulb sockets and all this coming at a smart switches. All these, the costs are reducing, and you can see them, and you can try to implement a smart home at your home using these existing devices. I'm not talking about building from the scratch, but if you are really interested, you can build something from the scratch as well, like an intruder alarming system. When an intruder comes to your home without notice, somebody opens the door, you can simply develop an alert system which come where a SMS is generated. Likewise, you can develop certain applications yourself as well. So I'll come into how to develop a solution in a while. So these are some of use cases like smart lighting and thermostats or door locks. All these things are currently available, right? So one other area that you need to think about is when you are innovating things, you have to think twice, because all these low cost, robust designs and commonly available things, if you are building any of these things, it is going to be reinventing the wheel. But if you are building a better version, if you are solving a problem with an existing system or a device will be a great thing, right? So you have to be careful about these things as well. Another very practical area, very interesting area is smart grid, where the power generation and the consumer side, power using side, power distribution side, all these things are smartly managed, which is currently available in some European countries, where they limit the power generation according to the consumption, and the consumption also smartly monitored, and according to that, distribution is uh, automatically adjusted. So those are, if all these ends are connected, much more efficient and much more sustainable power grid can be operated. So if we take something like smart grid, things like smart metering, smart appliances, load balancing according to the supply and demand, and smart generation. So these are some of the areas in the smart grid. And I think right now there were pilot projects done by few companies when it comes to smart metering of electricity, and smart water metering project is also currently rolling up. So I think in the future, hopefully we will see some smart metering projects going on, because simply honestly I don't believe I don't see any chance of implementing human resources to read a meter in another 10 years. So that is why, if you can refer to this future jobs report by World Economic Forum, you can see clearly there are certain jobs that are disappearing because of the technical evolution. Certain jobs are disappearing now. So in the next, there are jobs that is going to disappear in the next 5 years. There are jobs that is going to disappear in the next 10 years. So all you have to do is uh, equip yourself with the skills that are required for the future, not for the today, not for the past. Then only you can survive with this rapid phase of technology development. So that is about smart grid, and I just want to give you two examples. I don't want to show you very fascinating examples of Google, Amazon, and all that videos, because all you can go to the YouTube and watch these videos. I just showed these two examples to give you a short idea that these solutions exist and all. I am pretty sure that you all might have seen these. Some of you can check the videos on internet. Another popular area is industrial Internet of Things, which is the largest portion of IoT at the moment, where all the industrial sensors, actuators, and all those are connected. And it is the most widely used IoT application. That is where most of the widely used IoT applications are currently available, right? So this one, I just wanted to highlight that we just talked about all these smart homes and all that. So this one, I just wanted to highlight you that some of the projects that we have done with the Tea Research Institute too. So what we have done in the Tea Research Institute is based on the temperature, humidity, and the moisture content of the tea leaves. We control the damper speed, or the fans, dampen the fan speed in the tea weathering machines. So otherwise, all these machines are operating at a uniform speed. So if we can vary the speed, we can save energy. So by doing this research in collaboration with TRI, it was found that about 30% of the power consumption of a tea factory can be reduced. On the other hand, the second one that I have displayed is done for Ansel, where we develop an IoT monitoring system to monitor the production, downtime, fault of the glove knitting machines there. The other thing is a weather station project, and apart from this, we have done many weather station projects up to about 70 or 60 units. So it's all about monitoring the weather parameters, displaying that, storing that data for historical analysis and all that. And we have done this for a insurance client, where the weather data is used to check the authenticity of insurance claims when it comes to the agricultural sector, because the adverse weather conditions affect the cultivations, and the insurer, all these large cultivations are insured property. So that is why the significance of the weather data collection comes into play in insurance. So I just displayed this video about the weather stations. So this is about how you can see in the you can see the data weekly or monthly, and you can analyze them, and you can see how this data is represented in this dashboard. So even with this one, we use the open source platform, and there are many platforms available even if you are visualizing these data. And let's come into the cloud IoT platforms. So this is one of the parts that I need to invite you all to test it out first. So when it comes to cloud IoT platforms, there are few parts available in the cloud when it comes to IoT. The functions of a cloud IoT platform is mainly to manage the devices. All these connected devices has to be managed by managing, and on the other hand, the data management part, and the application integration part, and the security part. So the device management is actually adding the devices or registration, and removing the devices, changing the tags and all, the management of the devices, monitoring the condition, whether they are connected and all that, generating alerts, and authenticating the devices. So that is what done by device manager. So basically you have to understand is every cloud IoT platform has a device manager to manage the devices connected to the cloud platform. It's simply like that. On the other hand, data management you can do using various tools available in every platform. So what are the most popular cloud IoT platforms? So you can see, you can create accounts and test it as well. There's AWS and Azure, Thingsboard, Google. All of these popular big tech giants have IoT platforms, and you can see when all the big companies in the world are developing the same thing, there's a huge potential, or there's a huge market opportunity for that technology. That is why all these companies are running behind IoT, because there's huge potential in future, in very near future, when it comes to IoT. That is why all these tech giants are running behind IoT. And we also very commonly use the Thingsboard IoT platform. And if you are looking for a IoT cloud platform, you can use it on site as well, in your servers as well. So I can recommend that to any of you as well. So I just put this video just to show you. I just wanted to show you, this is a video in the AWS YouTube channel. You can check it online. So you can see a fascinating thing here, where what are the areas that they have implemented AWS IoT cloud. So then you will see that they are into these furniture, smart homes, energy generation, vehicle tracking. This is a mining solution that they have. So basically they have seen the opportunity that they can exploit each and every industry on planet using IoT. That is why they are very much fascinated about this technology, and they are also using that. You can check their IoT cloud platforms and what are available. Even free resources are available, and most of these platforms, they have free versions too for you all to test it out. And I'm sure students have some access to some of the platforms as well, so you can check it out, right? Okay. And on the other hand, another example that I can give you is Magic Bit is another product that we have done. So here I have, there are articles available. You can search online and see. So we have done some implementations with MagicBit and Azure integration. So what we do is using our MagicBit learning platform, which is a development board actually. So we have integrated that with Azure IoT platform. So likewise, you also can test and see some of your development boards, or maybe a circuit that you have done with sensors or IoT. So you can integrate that with an existing IoT platform, and you can see the features that you can use in other applications as well. On the other hand, magicblocks.io is a IoT platform that we have developed. So it's actually a learning tool, and it's freely available for anyone. You can just simply go to magicblocks.io and check out the features. And it's a visual code builder, and if you have knowledge in programming, definitely you can custom code as well. On the other hand, you can develop very simple applications as well as complex applications if you know programming, and it's made for learning for students like you. If you are doing any IoT projects, or maybe final year projects, you can use it for your projects. And we have a paid version of that as well, but for anyone it's available for 3 to 6 months, 3 months available, I think, the free version. And apart from that, you can use it up to about 1 year, where you will get a session about 2 hours in the IoT platform. And so hardware software integration can be done using this Magic Blocks IoT platform, and custom coding available. So you can check out this platform and see what you can do. So this is a simple video I have with this is the Magic Blocks app. You can download that as well, where you can implement, you can use the sensor, all the sensors in your phone with any of the IoT applications that you are developing. And this is the magicblocks.io platform, where you can name the devices, add the devices, and program them using visual coding. And you can connect devices. And this is our magic code, the Scratch version that we have developed for our MagicBit platform. MagicBit is our development board, and the Magic Blocks is the cloud-based IoT platform. And I'll show you a very short demonstration of using IoT platforms using Magic Blocks. And if you use any IoT platform, it's the same actually. So basically, right. So actually what you can do is you can go to magicblocks.io, and you can create a account there. And once you go that, you can see the device manager. I'll show you from the beginning. I think that will be better. Right. I hope you all can see. This is the screen that you get when you log into magicblocks.io platform. So here you can see the device manager we have available here. So you can connect devices. So this supports all the ESP32 supporting platforms. You can onboard it to here, and our Magic Bit development board has a ESP32 microcontroller, so ESP32 processor. So you can onboard that or any other ESP32 device here, and even without the devices using this one. So here the programming part is happening at the section called playground. So if I open up the section called playground here, it's taking a while because I think my connection is not stable. So if you are developing an IoT solution with some for the cloud development part, and you can develop the device to device communication part, the message passing part, and the algorithm in the cloud. Sorry, I think I just got disconnected. So what I was describing, okay, so what I was describing is this Magic Blocks platform. You can simply drag and drop blocks and connect. So this one I already put it here before starting the session, where I have a timestamp and I process to generate random when using different gauge. I visualize this with charts and gauges. I'll show you the charts as well. So this one is all this data is so as you can see here, let's see here. So you can see here, once I develop the code with the blocks there, gauges like this or charts like this, and visualize data very nicely using this platform. And if you take any of the IoT platforms like Things board also, you can develop this kind of a dashboard very nicely. And when you are developing a practical solution, you can use real sensors and capture this data, and using the protocols I mentioned like MQTT, you can handle the data in such a way where you get the data to this input here, and you can use it, visualize it using these graphical tools available in IoT platforms. And this is a very simple explanation of how we have displayed this data here in these graphs, right? So that is what I want to show you. Okay. Give me a minute. So actually what happened was I am using my presentation also online in a cloud platform. So sometimes when you are dealing with the cloud, this sort of delays and glitches sometimes happens, right? So that is the delay that I also had to face there. So that is the demo. I just want to show you how easily can you use magic blocks for IoT application. So I will tell you about innovation, why you have to, when you all know that you are all, most of the children in schools are going to do jobs that are not existing yet, and Sri Lanka is far behind the innovation compared to other countries, and we all talk about it, but yet only very small number of people are doing something for that. So I think for all the problems we have, like the hunger or the pollution, everybody's talking about these things, and there are simple facts that we cannot get rid of. For example, even we plant every inch of this planet with trees, now we cannot get rid of the carbon dioxide that we are emitting. The truth is that. So the only solution for all the problems that the humankind are facing right now is innovation. So people like you all have to come front and do innovations with these technologies to solve these burning problems. That is why I think people like Elon Musk or maybe other people are saying that the world's first trillionaire will be a person who is solving the climate problem in the world right now. So all the problems in this world is open for all of you to develop solutions with technologies like IoT. So that is the part I just wanted to cover. So to give you that message. And when you are developing innovations, think about unique and disruptive solutions, right? So it should be a very new thing. If you are going to innovate, simply replicating a project on the internet is not going to work. It is good to replicate the projects on the internet, watch the videos and replicating them, learning the, but you all you have to do is learn the basics of the project. So that is the part I just wanted to cover. So be very familiar with the basics. On the other hand, think about robust designs and the scalability of your designs, because if you, no matter if you design a very nice and a good product, if we cannot mass produce that, it won't be a good product, or it won't be a human consumable product. So think about the scalability and the robustness of a product or a solution. On the other hand, think about the economic feasibility. Everybody's talking about all these developing stuff locally, and how we can do our things on. But think about this for a while, that we are not alone in this world. Everything is connected now in the world. So we have to think about the economic feasibility and the superiority of our products as well. So those are some of the areas that you need to think when it comes to tech innovations. So when you are developing IoT solution, think about identifying a problem and define the parameters that you need to capture. Then do the hardware designing part, or else if you can get the hardware parts at a cheaper rate, or hardware parts where you can assemble into a solution, get those hardware. And if it's more economical, or if you can provide a quality solution with your customized hardware, design that hardware. And if you can do the software side, develop the software side or the cloud application side, integrate them. Nowadays it's not all about developing from the scratch. All you have to do is uh, put together the correct software and the elements. For example, if you are trying to develop an IoT solution from the scratch, from the cloud part itself, I think you are wasting time, because all these cloud platforms available have very powerful tools which we cannot design sometimes even for a very long time, because all these solutions have been developed by experts for a very long time. So some of the features we can use it very effectively for our problems. And sometimes for some simple applications, it's worth to develop from the scratch rather than using a paid platform. So it's a bargain. That is what you have to decide with your own knowledge. On the other hand, it's most of the time it's all about integrating stuff, and you have to do the testing and debugging part, and then you can go for a pilot run with the solution for the problem you identified. So that is the phases that you have to go through when you are developing a IoT solution. And if you are interested in hardware designing the IoT nodes or maybe gateways, so you have to be good about PCB designing, programming, all these areas. And programming, I mean the firmware, software, all these sides. So where you can start is applications of microcontrollers are everywhere. Most of these IoT nodes and everything have microcontrollers nowadays. So microcontrollers are becoming very popular in all these areas: wearables, mobiles, automobiles, robotics. So if you can learn microcontroller programming, and if you can expert that, it will be great, and it will be a good platform for you to go to the next levels as well. And as you can see, we also practice microcontroller programming when we were undergrads, and that's how we developed this MagicBit platform, which is a microcontroller programming board basically. So any student can use that as well. On the other hand, there are very popular platforms like Arduino, Microbit. So even with the MagicBit platform, what we were trying to do is overcome with the limitations that we had with Arduino or maybe Microbit. So we were trying to solve that problem. That's how we came up with MagicBit development board. On the other hand, we are actually, so I'll explain briefly before I end what we are doing. So basically, we are good friends. We are a team of engineers, myself, Anuruddha, Akalanka, Tilina. We all were batch mates some time back, and we are doing this electronics, robotics, IoT and software side R&D work in Sri Lanka, developing weather stations, educational platforms, industrial solutions. So we like to develop solutions for these things, like technologies like IoT mainly. So mainly with IoT, what we do is we do the dashboards for the industries. On the other hand, we do automations. And that's why I mentioned the Things node. You can check out the website thingsnode.cc. So which has our IoT node that we have developed with multiple communication methods and complying to all the industry standards. So it's an IoT gateway device and an end device, and a edge computing device as well. So we have implemented projects that I mentioned earlier. So you all can see that these things can be developed in Sri Lanka. On the other hand, MagicBit is our education platform that we have developed for the students to learn technologies like electronics, robotics, IoT, AI, ML, all using a single platform. And we have created this innovation environment for students with our hardware, with MagicBit, MagicBlocks, cloud IoT platform, and even the Scratch. We have developed our own version called Magic Code, and the mobile MagicBlocks mobile app also available. So you can see with mobile, cloud, and hardware, it's an integrated environment that we have created, which also has compatibility with MicroPython, Arduino, any of these resources as well. So this is our development board that we have developed, and I introduced the IoT platform for you all, which you all can freely use. You can check the IoT mobile app as well, where you can use the sensors in your mobile or maybe using your mobile as a output device to display a dashboard or maybe get a message likewise. So you can either use as an input device or output device the mobile using the MagicBlocks app for any of your IoT applications. So that's about what we do. So what is beyond IoT? All these solutions that I talk about, beyond there is analyzing the data, using the historical data for better decisions, identifying patterns. All this comes into analytics, data science side with AI, ML, big data, all these areas. And these areas you cannot get rid of in future. So I invite you all to learn about these areas as well. And that's about the session. Actually, I think I plan to finish on time with some time for you all to ask few questions. So the key take home message for you all from me is watch out for technological trends and use the knowledge that you have gained in the university or in your private life by experimenting. And on the other hand, develop robust innovating new projects. Then only you can take that to the industry. You cannot simply take DIY projects to industry. And Sri Lanka need lot more innovations in IoT space. On the other hand, think about the efficiency, cost effectiveness, and the robustness of your designs when you are developing solutions. With all that, if you are inspired to do my first IoT project, and if you think now that I have to start a project, I should check this on the internet. I think that's the inspiration I want you all to get out of this session, even if you forget each and every word that I say. So that's the only message that I want to be remain in your head for the next few years, because it's going to be dominated by IoT, whether you like it or not. So thank you, and I thank the KDU, IET KDU on campus branch for inviting me for this session and the opportunity provided by the faculty to conduct this session and share my experience with you all. I hope that some of the facts that I shared with you might be useful for you all, and I honestly tried to share my own experiences with you all. And I have mentioned the websites that I referred about our products and my involvement with some of these tech startups in Sri Lanka. So you can check these websites for more information. With that, if you have questions, I think we can have about 5 minutes if the organizers permits. We can have about 5 minutes if you have any questions, or we can end the session. Thank you all.
So thank you very much for that very interesting session. I'm pretty sure everyone gained a lot of knowledge from that, and it gave us a rather different view of IoT, I guess, from what we usually hear from various sources. So like Sir extended, the floor is open for any questions anyone might have. Please feel free to unmute your mics and go ahead with your questions.
Good evening, sir. This is regarding one of your lecture slides that you have explained us before. And the question is, sir, you've been mentioning that there are ill effects of IoT as well compared to the benefits as well. So when it comes to the cyber terrorism and the threats to the cyber security, what do you think of the approaches that we can go for when it comes to anti-cyber terrorism through IoT applications?
I think even in the military sector or even the security sector, there are many applications like it could be simply tracking vehicles, humans, or maybe identifying some of the parameters in different environments. Uh, so it could vary, and especially if we are thinking about any of these applications, as like you mentioned, one of the areas, whatever the application, the most critical part that we have to face is the security part, because uh, now for the learning purpose you can use these open source platforms, open platforms for all, and protocols without security. But if you are using for applications like high secured ones like you mentioned, you have to think about the protocol security, the physical security of the devices, and the security of the communications. Those parts we have to figure out, and for each of these layers there are secured versions and there are precautions you can take. So by implementing those, you can mitigate some of the issues that could arise. And if you take the areas you mentioned, I think you can think about enough applications when it comes to IoT, because there are so many improvements we can do for the existing world with IoT even in that area. So I think security will be the critical part. Other than that, many applications can be done and potential is out there.
Thank you very much. So I think that explains the question and what the girl wanted to know. If there's any other questions. As there seems to be no other questions, I think we can conclude the session for today. I will hand over the proceedings to the secretary.
Keynote speaker, Engineer Migara Amithodhana, Emeritus Professor, Professor J.R. Lucas, Dr. S.U. Dampake, the Dean, Faculty of Engineering, Commodore J.U. Gunasila, the Dean, Faculty of Computing, Captain K.K. Dadalage, HOD, Department of Electrical, Electronic and Telecommunication Engineering, board members of IIT on Campus KDU. Ladies and gentlemen, a very good evening to all you all. Addressing on behalf of the board members and general members of the IIT on Campus KDU, as the secretary, I would like to deliver a few words of appreciation to all who made this webinar a success. It is a great privilege for me to extend my sincere gratitude to Engineer Migara Amithodhana, the keynote speaker of the webinar, and a regional manager, SLT Mobitel, and an intellect behind ANT Labs, for accepting our invitation and gracing the occasion with your presence and ideology all about IoT. Sir, a token of appreciation shall be sent to you in due course. We are very grateful to Engineer Tilini Vasundara, Chairperson IET YPSL, and board members for the opportunity given commissioning the IET on Campus KDU, without which we wouldn't be able to organize this event. I would also be thankful to Professor J.R. Lucas, Dr. S.U. Dampage, Commodore J.U. Gunazila, Captain K.K. Dadalage, and Engineer Pasan Vellalage and Major R.M.C.P. Ranasinghe as advisors to IIT on Campus KDU for the guidance and supervision in making this event remarkable. I thank you wholeheartedly for your utmost diligence and for your presence. I am glad to extend my deepest sense of commendation to the President of SCADE, KAWPS Kasturiarachi, and all the board members and general members of IIT on Campus KDU. Your timely contribution for IIT on campus is highly appreciated always. Last but not least, a special thank goes to all our participants today from the universities island-wide for the humble acceptance of our invitation and for your participation today, without whom this event wouldn't have been a success. Hope we inspired you to build up your IoT knowledge for your career success today. Ladies and gentlemen, stay tuned for more chapters on how to write your success story. Once again, thank you very much. Have a pleasant evening.